So the charge across both of them should be the same. Individual capacitances C1 and C2 has to be calculated. Expression for energy, yes, E is half C V square. Hello students, this is your SD sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my previous session, I have started solving numericals of the chapter Electrostatic Potential and Capacitors, where my primary focus was on the concept of capacitance. In today's class, we will continue the discussion. We will solve few more problems from capacitors. Expect you have come prepared for that. Gone through the previous session and solved those problems. The first problem, two capacitors of 2 microfarad and 6 microfarad. There are two capacitors of 2 microfarads and 6 microfarads connected in series. Very important word to solve the problem. The two capacitors are connected in series across the 20-volt source. I have to find the charge on these capacitors and potential difference across each capacitor. Now, as we do, we will first note down the data. C1 is 2 microfarad and C2 is 6 microfarad. Again, I say a key word to analyze this problem is both of them are connected in series and they are connected across 20-volt source. You have to find the charge on these capacitors and potential difference. Note number 1, whatever may be asked to calculate charge, potential, energy, first calculate the capacitance of the combination, the so-called equivalent capacitance of the combination. Now they are connected in series, and remember, capacitors connected in series. So the formula CS equals C1, C2, C1 plus C2. This is capacitors in series. So CS equals C1, C2 divided by C1 plus C2. So on substitution, this is 2 into 6, 2 plus 6, 12 by 8. So this is 3 by 2 microfarad. So as the first step of calculation, I have calculated the equivalent capacitance, which is 3 by 2 microfarad. Now, the first part of the question says to calculate the charge on each capacitor. Dear students, know that here the two capacitors are connected in series. So the charge across both of them should be the same. Why? They are connected in series. Therefore, we know that C equals Q by V, or Q equals CS into V. Both the capacitors should have the same magnitude of the charge. So this is 3 by 2 into 20. So the answer is 30 microcoulomb. So the charge across each capacitor will be 30 microcoulomb. Now we need to calculate the potential difference across each. So V1 is the potential across the first capacitor, which is Q by C1, which will be 15 volt. Q is 30, C1 is 2. V2 is Q by C2, 30 by 6. So 6. So this is 15 volts. See? Very simple. A 5-mark question. Just know the relations. You can solve them very easily. The next one, students. Now, two capacitors of 3 microfarad and 5 microfarad are connected in series. Again, there are two capacitors. The capacitance of the first capacitor is 3 microfarad. Capacitance of the second capacitor is 5 microfarad, and they are connected in series. The first part of the question is to calculate the equivalent capacitance. Now, if a battery of EMF 10 volt is connected across them, calculate the charge on each capacitor and also the potential difference across each capacitor. Exactly as we did in the previous problem. Now, C1 is 3 microfarad. C2 is 5 microfarad. And they are connected across a 10-volt source. First, I will calculate the equivalent capacitance here. Again, they are connected in series as we saw before. So, CS equals C1 C2 divided by C1 plus C2. On substitution, 3 into 5, 3 plus 5, so which turns out to be 15 by 8. So this is 1.875 microfarad. Nodi, if you just know the expression for effective capacitance, either when connected in series or parallel, it is very, very easy for us to score 2 marks here. Next, as we did, charge on each capacitor should remain the same. Why? They are connected in series. So now, Q is CS into V, 1.875 into 10, which is 18.75 microcoulomb. See again, very simple. I have calculated the charge, which is the same on each capacitor. Now, potential difference across the capacitors. Again, V is Q by C1. Q is 18.75 micro. C1, 3 microfarad, 6.25 volts. This is V1. Q by C2. Similarly, you substitute. So this turns out to be 3.75 volt. Again, a very simple calculation. The next one, students. This is a very important problem. This is quite often asked in the exam. So we will concentrate on this. When two capacitors are connected in series and connected across 1 kilovolt line, the energy stored in the system is 2 joule. Andre, in simple to understand, when two capacitors are connected in series, the energy stored in the combination is 2 joule. when the same capacitors are connected in parallel and are connected across the same line, the energy stored is 9 joule. ಈಗ ನೋಡಿ, when the two capacitors are connected in parallel, the energy stored is 9 joule. Find the capacities of the capacitors. Andre, individual capacitances C1 and C2 has to be calculated as we did in our resistor problems. Here, they are connected across 1 kilovolt line. So the potential applied is 10 to the power 3 volts. We are connecting them across 1 kilovolt line. Now, when they are connected in series, when the two capacitors are connected in series, very clearly energy stored is 2 joule. Do you remember expression for energy? Yes. E is half C V square. So this is CS. Just to indicate it is energy stored in series. So this is 2 joules, half CS whole square, or CS is equal to 4 into 10 power minus 6. I call this equation 1. So very clearly, when two capacitors are connected in series, effective capacitance is 4 microfarad. Now, when they are connected in parallel, very clearly he says same two capacitors connected in parallel across the same line. Now the energy is 9 half Cp whole square, 10 to the power 3 whole square, 18 into 10 power minus 6. Now it is very simple from here. Since I know the value of Cs and Cp, I can frame two simultaneous equations and arrive at the answer. Now, I know Cp is C1 plus C2. When two capacitors are connected in parallel, Cp is C1 plus C2. But how much is Cp? 18 microfarad. So 18 is C1 plus C2. Call this equation 3. Just substituting for Cp. Cs C1 C2 so Cs is 4 C1 C2 divided by C1 plus C2 is 18. C1 C2 is nothing but 72. Equation 4. Now, as usual, we have equation of biquadratic, which says C1 minus C2 whole square is C1 plus C2 whole square minus 4 C1 C2. C1 plus C2 is 18 whole square, 4 C1 C2. So what do we get when we simplify? So we get C1 minus C2 is equal to 6. Now I have C1 plus C2 is 18 from 3. C1 minus C2 is 6. Two simultaneous equations. Solve them. C1 turns out to be 12 microfarad. C2 turns out to be 6 microfarad. And this will be the answer. The next one, students. A very beautiful problem. In the figure, the potential difference between A and B is 60 volt. What is the potential difference across 6 microfarad capacitor? To begin with, let us find the effective capacitance between A and B. If you observe the circuit, 3 microfarad and 3 microfarad are in parallel, which means the effective of this is 6 microfarad. So 6 microfarad, 3 microfarad, 6 microfarad and 3 microfarad are in series. So effective capacitance is 1 by 6 plus 1 by 3, 1 by 3. We take the LCM, 1 microfarad. So effective capacitance is 1 microfarad. Now the charge stored CS into V. So potential applied is 60 volts. So 60 microcoulomb. I want the potential across 6 microfarad capacitor. So V is Q by C into 10 power minus 6. So 10 volt is the answer. See, very simple. So we have worked out problems in today's session based on capacitors. By next class, I come up with problems on potential. Until then, have a nice time. Thank you.